Welcome everyone. It is 3 p.m. and it's time for the Server Room Show. This is episode 41. Today we will talk about monitoring software. I want to share something which I always forget to share, and then I always remember afterwards that one of the things I'm pretty much the most proud of regarding this if this live broadcast or podcast or videocast, however we want to call it. The main things I'm proud of are the thing that it's completely safe for work, for being the reasons that there is no bad language or swearing or these kind of inappropriate things in it. And the second thing pretty much goes hand in hand with this thing, that it's free from politics and these kind of opinions. The reason being, this is important because it happened to me on more than one occasion, that for example I wanted to show some maybe it was some YouTube videos about some IT topics, or maybe it was in an audio recording in a podcast form, and the content was interesting, and I wanted to share it with other people. The problem was that there was a lot of foul language in it and a lot of swearing, and you might not think, but there are a lot of scenarios where you just cannot get away with that. So think about, there are people who listen to this kind of podcasts or live broadcasts, or maybe look for these videos online, and maybe they have children, they have elderly people around, or they have their spouse, they have people around them, and obviously they don't want to expose them to this kind of experience, or how to say it. And on another scenario, which is even worse, because imagine it's let's say maybe like one of my previous videos, when I was talking about Kubernetes and Docker. Imagine I end up finding a great video on YouTube or a podcast which sums up how to get up and going in Kubernetes maybe, and I would like to share it and show it in my work to let's say to my manager or to some colleague of mine. And just with this kind of inappropriate language and not being exactly as the term says, safe for work, it can kill the whole experience or usefulness of it, because then immediately I have to sum it up myself, or I have to look for another source. So I always remember this, and I always wanted to share just to remind you people that I think that it's one of the cornerstone of this series, or this broadcast, or this podcast, or videocast, that you can feel free to turn it on or show it to anyone, no matter where you are. After this long introduction, which I normally cut down at since a friend of mine told me from cold Canada I was wasting too much time on introduction, I go back to short ones from now on. Monitoring softwares, I want to mention Nagios, Zabbix, and OpenNMS. The reason for monitoring softwares, why they exist and what they do in IT monitoring, is the process to gather metrics about the operations of an IT environment, both hardware and software, to ensure everything functions as expected, to support applications and services, because that's why we have the infrastructure to do things we needed to serve things for us, like a website or a database or an Active Directory server. Basic monitoring is performed through device operation checks, while more advanced monitoring gives granular views on operational statuses, including average response times, number of application instances, error and request rates, CPU usage, and application availability, for example. you get information or insights through monitoring software or infrastructure monitoring applications into hardware as of the physical health of the hardware. If there is any error, like regarding hard disks or regarding failures in RAM memory, for example, you get insights about operating system, its utilization and depletion, about the network, for example, like bandwidth consumption and errors. Regarding applications, you can monitor performance and most importantly, one of the most important is to monitor availability. IT monitoring covers 3 sections called the foundation, software and interpretation. Foundation is the infrastructure, is the lowest layer of the software stack and includes physical or virtual devices such as servers, CPUs and virtual machines. These metrics we mentioned regarding the hardware's health, if it's on, if it's off, and its utilization, if the CPU utilization is high, and how much disk space it has. The software layer, this part is sometimes referred to as the monitoring section, and it analyzes what is working on the devices in the foundation, just like I mentioned, including CPU usage, load memory, and running virtual machine count, for example. And the interpretation layer, where these gathered metrics are presented through graphs or data charts, often graphical user interface dashboard. Think about you can send these metrics, for example, most of these monitoring softwares we are going to talk about today, most of them has connectors or plugins for Grafana, for example, which can create very beautiful looking and useful dashboards to present the collected data. And this is often accomplished through integration with tools that successfully focus on data visualization. Grafana is exactly just what it means, as one of the examples for data visualization, amongst other tools. IT monitoring can rely on agents or be agentless. Agents are independent programs that install on the monitor device to collect data on hardware or software performance data and report it to management server. Agentless monitoring uses existing communication protocols to emulate an agent with many of the same functionalities. For example, to monitor server usage, an IT admin installs an agent on the server. A management server receives the data from the agent and displays it to the user via the IT monitoring system interface, often as a graph or performance over time form, like for example on a Grafana dashboard we just mentioned. If the server stops working as intended, the tool alerts the administrator, who can repair, update or replace the item until it meets the standard for operation. There is something called real-time versus trends monitoring. Real-time monitoring is a technique whereby IT teams use systems to continuously collect and access data to determine the active and ongoing status of an IT environment. Measurements from real-time monitoring software depict data from the current IT environment as well as the recent past, which enables IT managers to react quickly to current events in the IT ecosystem. Historical monitoring data enables the IT manager to improve the environment or identify potential complications before they occur, because they identify a pattern or trend in data form period of operation. Trend analysis takes a long-term view of an IT ecosystem to determine system uptimes, service level agreement, adherence, and capacity planning. Those are important to see, using the data which is presented to you to try to see, with the help of trend analysis, to try to see not just where you are today, but also where you're going to be, or what you will need 3 months down the road to meet those those required uptimes, or to handle that load on your website, increasing amount of visitors, for example, or how to load with how to deal with an increase in the load or in the user amount of user base. You have to, for example, have those Active Directory servers, domain controllers to serve. If those numbers, imagine, goes up, then you have to plan ahead, and with trend analysis you will see if, let's stay with the example, if 3 months down the road your current system in the state as is during normal business operation, if you are going to able to maintain and comfortably meet those agreements or serve that capacity, or you need to plan now for 3 months down the road to be able to meet what the business expects from the IT infrastructure, because you have to be proactive. It's always better to be proactive than reactive, and it's more than true when it comes to your whole IT infrastructure, what the business relies on. Two extensions of real-time monitoring are reactive monitoring and proactive monitoring, just like I mentioned. The key difference is that reactive monitoring is triggered by an event or problem, while proactive monitoring seeks to uncover abnormalities without relying on a trigger event. Exactly like that. The proactive approach can enable an IT staff to take action to address an issue, such as a memory leak that could crash an application or server before it becomes a problem. Originally, I didn't want to talk about this piece of software or mention it, but this part in the show notes, I could really make a good example here with a piece of software we use at work called Nexthink, which on its very core, apart from the many things and the fancy things it does, on its real core, Nexthink is a real-time analytics and insights piece of application. Therefore, we could say that it's in some form or in some capacity, it is a monitoring application. It obtains real-time actionable insights, and what the way we use it at work is we have this Nexthink agents on all the computers, end user computers. Let's mention end user computers now, and it constantly monitors every little single thing. So when you look at the Nexthink dashboard and dig deep down on a specific computer, you can see the uptime, you can see information which all the time comes handful when you're dealing with Windows machines, like how many blue screens of that event it had, how many X or Y type of events it had in its event log lately, how many application crashes, how many software crashes, how many software got installed, how many of software were in a hang state, and it gives you quite a good insight on what actually goes on a user's computer. And what else it does, it's benchmarking and proactive improvement, that it uses kind of like baseline scores to try to taking all this data in account and come up with an overall score regarding the health of the machine and regarding the possible user experience in a numeric form. So imagine on a computer where there are frequent application crashes and its event log is full with let's say critical type of error messages, and constant driver failures occur, obviously, and for example, even let's say maybe the logon time and the boot time of the machine is long on that machine, the overall score when it comes to how it's evaluated as a user from user's point of perspective is gonna receive a very low score, and this will appear in this dashboard, and it can trigger certain automation such as sending a task or a ticket to IT technicians to replace perhaps the user's computer if it's more than X years old, or if it's not such an old device. Let's say it doesn't even have 2.5 years, and every 3 years they got replaced. Then perhaps it says let's send a ticket to the technicians just to have a look at it. So by the time the user, probably him or herself, would open the ticket, IT analysts already know about it, and they can act upon it. I wanted to mention Nexthink because even though it specifies and very specific into this type of monitoring in this scenario as we use in job at work, it's a great example of how this the real time and the trying to project and figure out the trend with what's going on with the machine, it comes together in this one single piece of application. Point in time versus time series monitoring. Point in time analysis examines one specific event at a particular instant. It can be used to identify a problem that must be fixed immediately, such as a 100% full disk drive. Time series analysis plots metrics over time to account for seasonal or cyclical events and more accurately recognize abnormal behavior. Point-in-time analysis relies on fixed thresholds, while time series analysis employs variable thresholds to paint a broader picture and better detect an event better detect and even predict anomalies. IT infrastructure monitoring. IT infrastructure monitoring is a foundational level process that collects and reviews metrics concerning the IT environment's hardware and low-level software, as we already said. Infrastructure monitoring provides a benchmark for ideal physical systems operation, therefore easing the process to fine-tune and reduce downtime, and enabling IT teams to detect outages such as an overheated server. Server monitoring and system monitoring tools review and analyze metrics such as server uptime, operations, performance, and security. As more organizations embrace cloud computing, cloud monitoring capabilities and options have expanded as well. Cloud customers can get visibility into certain metrics such as CPU memory and storage usage to gauge how well their application perform, but the nature of cloud infrastructure limits the view into the physical assets on which cloud workloads run, because they don't need to know, the clients. Only the people who run the cloud needs to know. So if it's a Google data center, the Google guys need to know what's exactly the underlying infrastructure and how it's behaving under the same load or in the same capacity. Network monitoring seeks out issues caused by slow or failing network components or security breaches. Metrics include response time, uptime, status request failures, and HTTP, HTTPS, SMTP checks. Security monitoring focuses on detection and prevention of intrusions, typically at the network level. This includes monitoring for vulnerabilities, logging network access, and identifying traffic patterns in real time to look for potential breaches. Application performance monitoring. Application performance monitoring gathers software performance metrics based on both end-user experience and computational resource consumption. Examples of application performance monitoring provided metrics include average response time under peak load, performance bottleneck, data and load response times. Cloud providers largely support application performance monitoring capabilities with their own native tools. Cloud customers can also choose from many third-party application performance monitoring tools to see metrics on resource availability, response times, and security. Application monitoring is within the scope of application performance management, a concept that involves more broadly controlling an application's performance levels. I want to mention some IT monitoring tools, just very briefly. For application performance monitoring, you have tools from Cisco, BMC, Microsoft Azure Application Insights, Manage Engine, for example, also making application performance monitoring tools, SolarWinds, also IT infrastructure tools like again Manage Engine, Microsoft System Center Operations Manager is a known one. Nagios XI, the paid version of Nagios, can be also mentioned. SolarWinds again, VMware's vRealize Operations, and Zabbix, for example, another one I want to talk about today. Cloud monitoring tools, Amazon CloudWatch, Google Stack Driver or Google Cloud Console, Microsoft Azure Monitor, Cisco Cloud Center, and Oracle Application Performance Monitoring Cloud Service. On the containers, microservices, and distributed application monitoring tools like Prometheus or Confluent, Kafka, Jaeger, and Lightstep. There is also log monitoring tools, which is important because logs are important, like Splunk, Fluentd, and Elasticstack. And then you have network security monitoring tools. For example, the PRTG network monitor is a quite nice one. So we got to Nagios, also known as Nagios Core, which is a free and open source computer software application that monitors systems, networks, and infrastructure. It offers monitoring and alerting services for servers, switches, applications, and services. It alerts users when things go wrong and alerts them a second time when the problem has been resolved. Nagios was originally designed to run under Linux, but it also runs well on other Unix variants. It is a free software licensed under the terms of the GNU license. Nagios Core is open source. It currently provides monitoring of network services, HTTP, POP3, SMTP, SSH, FTP, and so on, monitoring of host resources, processor load, disk usage, system logs, on majority of network operating systems, including Windows. It uses monitoring agents, monitoring of any hardware, like probes for temperature and alarms, which have the abilities to send collected data via network to specifically written plugins, monitoring via remotely run scripts, for example, Nagios Remote Plugin Executor, remote monitoring supported through SSH or SSL encrypted tunnels. It has a simple plugin design that allows users to easily develop their own service checks depending on needs and using pretty much their choice of tools. It could be shell scripts, it could be C++, Perl, Ruby, Python, PHP, C#, and so on. It has available data graphing plugins, so depends on your needs. You maybe don't need to go and use data visualization tools like Grafana. It can do parallelized service checks. It has flat text formatted configuration files, which integrates very well with config editors. There are also a couple of GUI tools to help you configure Nagios and its configuration files easier. It can contact notifications, service or host problems and have them resolved. It can alert via email, pager, SMS, or any user-defined method through, again, this plugin system it has. It has automatic log file rotation. It supports redundant monitoring hosts. It supports implementing performance data graphing, like for example you can connect it to another system like Grafana, which takes care only to visualize the data. It supports database backends, push notifications, and you can also use its web interface for viewing current network status, notification problems, history, log files, and so on. I will jump over the agents part because I have a little time left as always. All you need to know that it has a paid version apart from Nagios Core, which called Nagios XI or 11, depending on how you want to pronounce it, and it can be handy for companies who want to have it with support. Zabbix is another one, which again an open source monitoring software. It includes network servers, virtual machines, and cloud services monitoring. It's very diverse. It is, I think it looks, for me, for the eyes, a bit more well-rounded than Nagios in the first place. Definitely, as Nagios uses those configuration files to know about its environment, Nagios is not very good when it comes to scalability. So even though you can use some GUI tools, as I mentioned, Zabbix is definitely better when it comes to when you scale it. You don't really need to dive deep. You can do most of the configuration of Zabbix through its web interface. It can run pretty much on anything, because it has a wide variety of options to be installed. You can do simple checks, can verify the availability and responsiveness of standard services such as SMTP or HTTP without installing any software or on the monitored host. However, Zabbix also uses agents, which you can install, for example, on Unix and Windows hosts to monitor statistics and more in-depth information like CPU load, network utilization, disk space, and so on. But yes, you have alternative to using Zabbix agent on the host. You can do, as mentioned, monitoring via SNMP traps, TCP and ICMP checks, or through IPMI and SSH or Telnet. You can use custom parameters. You're not limited just to agents. In this sense, it's similar to Nagios. And if you look at my screen, you can see that it definitely looks a step up from Nagios from my point of view. And as I said, it's easier to have it up and running and do the configuration. You don't need to edit those text files like in Nagios. And OpenNMS, which is again an enterprise-grade integrated open source platform to build network monitoring solutions. The good thing, because I only have 2 minutes left, to sum it up, OpenNMS from the very beginning was built with scalability in mind. Scalability and modularity or extendability, so to say. It uses a lot of REST APIs. It can integrate with various notification systems, can use customized or external scripts. You can have it integrated with ticketing systems like Remedy or IBM's Tivoli or Jira, or you can use your own API thing to communicate with your own ticketing system. It has a Java-based framework, and as I mentioned, the most important in OpenNMS, that it also has a free edition and enterprise supported version. It's very, very scalable. Nagios and I think not even Zabbix comes close to when it comes to scalability for OpenNMS, and it's made to be able to handle tens of thousands of devices and a lot of events coming in and out. It is a really robust. So if I had to choose from Nagios, Zabbix, and OpenNMS, because of all that possibility to integrate it with other systems like ticketing and the notification, I probably would choose OpenNMS. Zabbix is a step up from Nagios, as I mentioned. It's easier to configure, but it is not as robust and as scalable as far as I saw and understood, like OpenNMS.